Welcome to the session 6 of module 4. In this session, we are studying about synchronous sequential circuit analysis. We are studying about synchronous sequential circuit analysis and analysis principles and analysis example. We are taking one example of synchronous sequential circuit and we are following the steps, analysis principles in order to derive the state diagram or state table. Synchronous sequential circuit analysis. What is analysis? Analysis of state machine is the process of working from a logic diagram to develop a state table and state diagram. We will be having a synchronous sequential circuit. We have to derive the excitation and output equations of that, and we have to determine the type of the flip-flop, and we have to write the next state equations. And after getting the next state equation, we have to construct the next state table. And after getting the next state table, we can easily write the next state diagrams. And this is the way we have to get the state diagram or state table from the logic diagram which is given. And these are the steps that we have to follow while analyzing the synchronous sequential circuit. We are having total 8 steps that we have to follow. First step is determine the system variables, input, state, and output. The synchronous sequential circuit will be having a combinational logic circuit. Along with that, we are having the flip-flops, that is the memory element. We are having flip-flops and combinational circuit. And first step is we have to determine the system variables. For the circuit, we will be having input, and we have to find out that input variable. And state variables, we have to determine the state variables. State variables are nothing but output of the flip-flops or next state of the flip-flops, and output variable. We have to determine these three. And the second step is we have to assign names to the variables if they are not clear from the logic diagram. In order to write the transition table and state table, we have to assign the names to the variables if they have not provided. And the third step is determine the flip-flop type. In the diagram, we can easily find out, easily come to know what is the type of the flip-flop. And we have to know the characteristic equation of that. And in some circuits, we may have different types of flip-flops. At that time, we have to know the characteristic equation of those flip-flops. The next step is write the excitation equations by inspection from the logic diagram. We have to write the excitation equations by inspection from the logic diagram. By seeing the logic diagram, we can easily get the excitation equations. Excitation equations are input to the flip-flops. Those are inputs to the flip-flops. Right, next step is write the next state equations for each state variable. For each state variable means output of the flip-flops. The next state of the flip-flop, we are calling it as a state variable. Okay. For this, each of the state variable, we have to write the next state equations using the flip-flop characteristic equations and the circuit excitation equations. The characteristic equation is specific to the flip-flop, and the circuit excitation equations will be different for different circuits. And while writing this next state equations for each of the state variable, we are having different types of flip-flops. Okay, for SR flip-flop, what is the circuit characteristic equation? For the SR flip-flop, the next state of this SR flip-flop is S plus R bar Q. In the same way, for the JK flip-flop, what is the for the JK flip-flop? The next state equation is JQ bar plus K bar Q. And for the D flip-flop, what is the next state equation? For the D flip-flop, it is very easy. So for the simple diagrams, we are considering the D flip-flops. Okay. And for the D flip-flop, the next state is QT plus 1 is equal to D. As we know, the D flip-flop is a data flip-flop or delay flip-flop where we are having the same output for the given inputs. Okay. And next, for the T flip-flop, what is the next state equation, characteristic equation? It is T XR Q, which is nothing but T bar Q plus T Q bar. T bar Q plus T Q bar. And here, by having the logic diagram, by seeing the logic diagram, we can easily come to know what is the type of the flip-flop, and we have to know what is the characteristic equation of that. And then by having the characteristic equation and circuit excitation equations, we can easily write the next state equations. And the next step is write the output variable equations. We have to write the output variable equations, and by seeing this output variable equations, we can easily determine what is the type of the circuit, whether it is a mealy circuit or Moog circuit. When we call it as a mealy circuit, whenever it is a function of input variable and its state variable, then we are calling it as a mealy circuit. And whenever the output variable is function of only the state variable, then it is a Moore circuit or Moore machine. We can have this state machine and sequential circuit, both are same. Okay, we can use any name. And the next step is construct the transition table, identify all of the states possible. Identify all of the states possible for a given number of state variables. If you are having 2 flip-flops, you will be having 2 state variables. If you are having 3 flip-flops in the circuit, we will be having 3 state variables. Okay, we have to identify all of the states possible for a given number of state variables. If you are having 2 flip-flops, then you will be having 2 power 2, that is equal to 4 number of states. Okay, we have to identify all of the states possible for a given number of state variables. And the transition table is determined by the evaluation of the next state equations. We have to evaluate this next state equations. Okay, how we evaluate this next state equations? For that, we should have the excitation equations, and then we should have the characteristic equation. Okay, by having this excitation equation and characteristic equation, we are finding out or evaluate the next state equations. Okay, and then we can, by substituting the input variable values and the present state values, we can easily find out the values for the next state equations, and we can generate the minterms whose output is logic high. And the next step is assign symbols to the states and construct a state table or state diagram. Here, while writing the transition table, we are using the binary values, that is 0, 0, 0, 0, 1, 1, 0, 1, 1, depending on the number of states we are having. Okay, we are writing the binary values. But while writing the state table, state table, we have to assign symbols to the states. We have to assign symbols to the states. Okay, if you are having 4 states, we can assign the symbols to those. Okay, we can use the alphabets for assigning the states. And after that, we have to construct a state table. And after constructing a state table, it is easy for us to write the state diagram. And last step is, if possible, we can construct a logic diagram. It is optional. Sometimes the number of input and state variables makes this task impractical. The main important steps we are having here is 8 steps that we have to follow. Okay. And we will take an example of a synchronous sequential circuit and we will analyze that. And we follow the steps that we explain now, and then we can try to understand those steps and we will derive the state table and state diagram. We are taking this analysis example. Okay, we are taking this analysis example and we are deriving the first step. In first step, what we are doing, we are finding the input variables and the state variable F1, F2, okay, and then the excitation equations and then the output variable. Here, what are the state input variable that we are having? We are having X, and the state variables we are having F2 and F1, and the output variable is Z. Okay, and after that we have to check for the names for the variables. Here all the names are given, no need of again assigning the variables. Okay, and then the next step is we have to write the check the type of the flip-flop, and then we have to write the characteristic equation. Here, what is the type of the flip-flop? The type of the flip-flop is D here. What is the characteristic equation of that? That is QT plus 1 is equal to, this is the characteristic equation of the D flip-flop, which means that whatever input we are providing, that will be our next state after the clock pulse. And now we will see the steps, and then we'll understand each step. The first step is determining the state variables. First step is determining the system variables. Here we have to determine the system variables. The system variables means input, output, and state variables. What is the input here? Input is X, output is Z, and the state variables are F2 and F1. Assign variable names. Here, if they don't mention the variable names, we can find out, we can assign the names for the variables. Okay, in this example, it is clear, so no need of assigning the variables. And we know that the type of the flip-flop we are using here is D flip-flop. Okay, we are using here is D flip-flop, and the characteristic equation is QT plus 1 is equal to DT. The next step is write the excitation equations by inspection. Okay, we have to write the excitation equations by inspection. Here, by seeing the diagram, we can come to know that the inputs of the flip-flop, excitation equations are inputs to the flip-flop, which excites the flip-flop to give us the next state. Okay, D2 is equal to F2 bar F1X, D1 is equal to X bar plus F2 bar F1. We know, we try to understand how we get this excitation equations. Okay, you see this diagram. Here we are having D flip-flops, and here we are having the inputs to this flip-flops. That is, we are having a combinational circuit for the combinational circuit as an input to this flip-flop. Here, what is the combinational circuit we are having? We are having the AND gate here. What are the inputs to this AND gate? One input we are getting from the F1 state variable, and other input is X. So T2 is equal to F1 into X. Now, what is the input for this D1 flip-flop? D1 flip-flop, we are having 3 gates here. One is OR gate, AND gate, and NOT gate. Okay. What are the inputs to this AND gate? One input is from F1. Okay. And another input is from this second flip-flop F2 bar. Okay. Another flip-flop output, that's F2 bar. Plus, here what we are having NOT gate here, and it is the input we are getting is from X. Here what we get, the output of this NOT gate, that is X bar. These two are the excitation equations. Whichever diagram they give, first step is to write the or determine the input variable, output variable, and the stage variables. Okay, and after that we have to assign the names for these variables if they have not mentioned. Here it is clearly mentioned, that's why no need of assigning the variable names. And then the third step is we have to find out the excitation equations for the flip-flops. We have done this. Okay. Now we will try to understand the next step. Okay. What is the next step here? It is write the next state equations. Writing this next state equations is very important. And for that we have to know the procedure how to do that. Okay. For D flip-flop is very easy because whatever the input that we are providing or excitation equation is there, that will be our next state. Okay. So F2 plus is equal to F2 bar F1x. Why? Here D flip-flop is having the next state equation, that is Qt plus 1 is equal to T. Okay, for the D flip-flop. But for other flip-flops, it is different. For other flip-flops, it is different. That is for SR flip-flop as we studied. Okay, SR flip-flop, the next state equation is given by Qt plus 1 is equal to S plus R bar Q. And for JK flip-flop, it is J bar Q plus, JQ bar JQ bar plus K bar Q. And for T flip-flop, it is T XR Q. Okay, now these are the characteristic equations that we know for the flip-flops. And now, while writing the next state equations, if they give other than this D flip-flop, what we have to do is, let us consider the T flip-flop. What is the T flip-flop? It is T XR Q. Okay, let us consider T input is F2 F1x. Okay, and now while writing this next state equation for the T flip-flop, what we have to do is, let us consider F2 plus is equal to F2 bar F2 plus, we can write it as, I'm explaining for the T flip-flop now. F2 plus is equal to T2 XR Q. Okay, T2 XR Q. Here, what is T2 here? I have considered F2 bar F1x. I have to substitute this value T2 here in this equation. Okay, and here what is T2 XR Q? T2 Q bar plus T2 Q bar plus T2 bar Q. I have to substitute this T2 value in the next state equations. That is the important thing that you have to remember. Okay. Here the next state equation is F2 plus, which is nothing but F2 of T plus 1. That is the next clock pulse. This is the output. F2 bar F1x. This is the equation for the D flip-flop. But if you are considering the other flip-flops, if the diagram is having other flip-flops, then we have to write like this. Okay. First, we have to consider the excitation equations for those flip-flops. And after finding out the excitation equations, we have to write the next state equations. In the next state equations, depending on the flip-flop type, we are writing the next state equations. And we are substituting the values for T, J, K, S, R. Okay, respective excitation equations for those inputs. Okay, that you have to remember. But for the D flip-flop, it is easy because whatever the next state excitation equation is there, that will be our next state equation. Okay, so it is easy. For other flip-flops, we have to substitute the excitation equations in the next state equation. Okay, excitation equations means the inputs for the flip-flops. Okay, while the next state equation consists of those inputs, that is T, J, K, and SR in the next state equation. For those values, we have to substitute for those inputs, we have to substitute the excitation equations, and we have to find out the next state values. Okay. Here for the D flip-flop, the next state equation is same as it of the input. Now we'll see the next step. Step 6 is write the output variable equation z is equal to f2x. Here, by seeing this diagram, we can come to know the output variable value. Here, what is that? Z is equal to f2 dot x, and operation between f2 and x. And after finding out all the values, we have to construct the transition table. The transition table consists of the present state, input, next state, and output. Okay. Here, we are considering the input in the separate column where we are writing it as 0, 1, 0, 1. If you can write in the other way also. We can consider x here. Okay, x here in this. Okay, x is equal to 0 and x is equal to 1. We have to make two separate columns for each of the next states. Okay, and here I am considering in the as a separate column. Okay, and here we are having the present state, that is state variables f1, f2, and input variable is x, and the next state we are having f2 plus and f1 plus. And we know the next state equations for this f2 plus and f1 plus. That is f2 plus is equal to f2 bar into f1 into x. f1 plus is equal to x bar plus f2 bar into f1. Okay, and the output is that is equal to f2 dot x. Okay, here we have to write the states, present state values, the input, and the next state we have to find out by substituting the values of f2, f1, and x in the equation, and after that we have to write the we have to find out the values. Okay, here f2, f1, x. We are substituting these three values in these equations, and here we are having f2 bar, f1, x. This is the AND operation. When we are getting high here, when f2 bar is equal to 0 and f1, x both are high. Okay, since it is AND operation, when all the three inputs to the AND gate is high, then only the output will be high. For other conditions, it will be 0. So we are getting this only for only one combination, that is f2 bar, that is f2 is 0, f2 bar is 1, 1, 1, 1. The output is 1, and for others it is 0 because here f1, x both are 0, so 0. If any of one of the inputs to the AND gate is 0, the output will be 0. See here f1 is 0, so 0, x is 0, 0. Here we are getting high, here both are 0, so 0. F1 is 0, 0, X is 0, 0, okay. Otherwise, you can easily come to know that 0, 1, 1. 0, 1, 1 is nothing but minterm 3. Okay. For the minterm 3, we have to write the logic high. For others, it is 0. Okay. And the next state is state, that is F1 plus equation is X bar plus F2 bar F1. Here also we have to substitute the values, and we are finding the values. Otherwise, what we can do is we can convert this next state equations into a canonical form, and we can easily find out, okay, the minterms. We can do in any way. Okay. Otherwise, if you know the K-map properly, we can easily find out how we are getting this simplified expression. Okay, what midterms we are grouping. By having that method also, we can easily come to know what are the outputs. Okay. Next, F2x. F2x means here we are having all three variables. We can easily find out the midterm. Here one term is missing here, that is F1. Okay, F1 F2x and F1 bar F2, F2 F1 bar x and F2 F1 x. That is midterm 5 and 7. Okay. In this way, we have to construct the transition table. Transition table contains the present state and next state outputs, okay, which we are mentioning in the form of binary values. And the next step is here we are simply writing the schema, okay, to know the what is the expression. Okay, here midterm 3 is high for this F2 plus. Here we are having the midterm 0, 2, 3, 4, 6. If we simplify that, we are getting the same equation for the F1 plus. And here midterm 5 and 7. Okay, if we simplify this, we are getting F2 and X. Okay. And the last step is assign symbols to the states and construct a state table or state diagram. After writing this transition table, we are assigning the states to this. We are assigning the states to this. Here, F1, F2 is 0, 0. Okay, for 0, 0, we are assigning one symbol. For 0, 1, we are assigning one symbol. And for 1, 0, we are assigning one symbol. And 1, 1, we are assigning another symbol. Okay, so for the same state, we are having two inputs, x is equal to 0 and x is equal to 1. Okay. Now we are having state symbols for these values, state values. Here for F1, F2, 0, 0, we are assigning the state symbol as A, for 0, 1, B, for 1, 0, C, and 1, 1, D. Okay. After assigning the symbols to the state values, okay, we have to write the state table. Okay, state table. This is the state table. Okay. The state table contains the present state, next state, x/z. Okay, we can write this transition table in this way also, but here we are writing the states in terms of symbols. That we were writing in terms of values, binary values. Okay, here we are writing the values. We are assigning the variable. We are assigning the symbols for this transition table. Okay, here we are assigning variable A for this, B, C, and for this D. Okay, and here we can write this table in the other form also that I explained. Okay, here when it is in state A, when x is equal to 0, x is equal to 1, what is the next state? Okay, when it is in state A, when x is equal to 0, it goes to state B. Okay, here you have to consider both F2 plus and F1 plus. For B, what is the values that we are having? For B, it is 0, 1. For C, 1, 0. And for D, 1 1. So here when it is in present state 0 0, when x is equal to 1, it will be in the same state A. So it is A. When it is in state B, that is 0 1, okay, when x is equal to 0, it will be in the same state B. And what is the output? 0. When it is in state B, when x is equal to 1, it will be in the state, it will go to the state 1 1. What is 1 1? Here it is. Okay. When it is in state C, when x is equal to 0, it goes to state B. When it is in state C, when x is equal to 1, it goes to state A. That is 0 0 means A. Okay, A value is 0 0. Now, when it is in state D, that is, what are the values? 1 1. When x is equal to 0, it goes to state 0 1. Okay, what is 0 1 here? B. When it is in state D, when x is equal to 1, it goes to state E, that is 0 0. And what is the output? 1. Okay. Now, by having this transition table and by having the symbols for each of the states, okay, state values, we have to write the state table. Okay, we have to write the state table, and then we have to in turn write the state diagram by having the state table. Here, the same thing we are writing in this way. When it is in when the circuit is in present state A, when x is equal to 0, it goes to state B. It transits to state B. And what is the output? Output is 0. And when it is in state B, when x is equal to 0, it will be in the same state B. What is the output? Output is 0. When it is in state C, okay, when x is equal to 0, it will be in the same state. It goes to the state B, and the output is 0. When it is in state D, when x is equal to 0, that is input is 0, it goes to state B, and the output is 0. And here we are writing the x separately, okay, x separately. X is equal to 0 and x is equal to 1, and z is also for x is equal to 0, and this z is for x is equal to 1. And then when it is in state A, when x is equal to 1, the circuit will be in the same state and output is 0. When it is in state B, when x is equal to 1, it goes to state D, and what is the output? Output is 0. And when it is in the present state C and x is equal to 1, output is 1. When it is in present state D and x is equal to 1, what is the output? Output is 1. So here we are writing the state table, and after writing the state table, depending on the states, present states, okay, first what we have to do is we have to write the state diagram. How many states are there? 4 states are there. Okay, A, B, C, D are 4 states. Okay, here A, B, C, and D. We are having 4 states. 4 states we have to write. Okay, we have to write the circle, and inside that we have to write a state variable name. And then we have to write the arcs, okay, directed arcs between these states depending on this state table. Okay, and here when x is equal to 0, when it is in present state A, it goes to state B. When it goes to state B, when x is equal to 0. Okay, and what is the output? Output is 0. Okay, Here it is 0. Okay. Now, when it is in state A, when x is equal to 1, it will be in the same state A. It will be in the same state A. That is, x is equal to 1 and the output is 0. Now, when it is in state B, okay, we will be having two inputs, x is equal to 0 and x is equal to 1. Okay, when it is in state B, when x is equal to 0, it will be in the same state. And what is the output? Output is 0. And when it is in state B and x is equal to 1, it goes to state D. It goes to state D. When x is equal to 1, and what is the output? Output is 0. Here the output is 0. Next, both the inputs over x is equal to 0 and x is equal to 1. When it is in state C, when x is equal to 0, it goes to state B. Okay, when it is in state C, when x is equal to 0, it goes to state B. And what is the output? Output is 0. When it is in state C, when x is equal to 1, it goes to state A. It goes to state A. And when x is equal to 1, what is the output here? Output is 1 here. That is equal to 1. When it is in state D, when x is equal to 0, it goes to state B. Okay, it goes to state B. When it goes to state B, when x is equal to 0 and output that is equal to 0. Okay, when x is equal to 0 and output that is equal to 0. Here 0 represent bar. Okay, and the variable represents 1 represents the variable. Okay, and next here when it is in state D, when x is equal to 1, it goes to state A. It goes to state, when it is in state D, it goes to state A. That is, x is equal to 0 and the output is 1. Okay. In this way, we have to write the state diagram. We can see this diagram where we are writing first the states we have to write. We are having 4 states here, A, B, C, D. Okay. We have to write the states inside the circle, and then we have to write the directed arcs to the other states as the states transit from one state to the other. Depending on the input, we have to write the directed arcs. Okay, depending on the input and the output. Okay, we have to check the next state and then we have to write the input and output above the directed arcs. Okay, okay. Beside this directed arcs, we have to write the input and output. Here, this is the input and this is the output. Okay. In this way, we have to derive the state diagram from the synchronous sequential circuit which is given. Okay. In this session, we studied about the synchronous sequential circuit analysis. Okay. We studied the steps that we have to follow while analyzing the synchronous sequential circuit, and we have taken an example and we understand the steps that we have to follow while simplifying the synchronous sequential circuit to derive the state table and state diagram. Okay. Thank you for attending this session.